what comes next? Yeah. 7. What comes? Yeah, tell me. What about 8, guys? No, 8 is like 2 times 4, or yeah. 11, is 11 the next one? Yeah. What about after 11? 12? Sarah? 13, and so forth. 17. It goes on forever. Okay, I can't list them all, but you get the idea. Does that make sense? Okay, so. How did you get these numbers? So you just kind of go in order. You say, is 2 a prime number? Yeah. Is 3? Yeah. Is 4? No. So you kind of keep going. There isn't a rule. You just have to, yeah. Any question? Yeah. So then what do you think? On your homework, it's going to ask you to find prime factorization of a positive integer. Have you guys heard of prime factorization before? We just heard of prime. We know what prime numbers are, right? Factorization, what does that sound like? What do you think that's included in there? Caroline? Yeah.
It's like where you have a number and then you have like this tree thing or something.
That's right.
And you take 2 numbers, 2 of its factors, and
you keep going down and so
yeah.
forth. What is she describing? This is well known as tree diagram, or we call it factor tree. So basically what you're doing, you just make a factor tree. When they ask you to do a prime factorization of a number, okay, you do a factor tree. Okay. And this is important. When you do a factor tree, at the end of the tree, when do you stop? When do you stop until you keep going, and then you stop when you reach a prime number? That's why it's called prime factorization. So when they talk about prime factorization, you're basically doing a factor tree. Does that make sense? And at the end, I want you to write the number in exponential form. Is that okay? Whenever we do a prime factorization, I want you to write the numbers in exponential form. Okay? Does that make sense? So go ahead and do this example 2. It says find the prime factorization of 504. Okay, everybody try this. Okay, see if you guys remember how to do factor tree. Okay, go ahead. So you have to go all the way till you reach the prime number. You guys remember that? And then I want you to circle those, okay? Because those are called the leaves. Do you know why they're called the leaves? Yeah, you can see at the end of the tree. Okay, anyway, so I want you to circle those leaves. Anyway, go ahead, try this. Okay. So, by the way, I did my tree this way. Oops, by the way, do all of our tree have to look the same? No, it depends on how you started off, right? It will look different. But at the end, should we get the same answer? Same prime factorization? Yes. In other words, should we all have the same leaves at the end? Yes. If we don't, then you did something wrong. So guess what I did first? 504, I used the rule 4. So and sometimes people like to do the one that are closest to, you don't have to do the closest number. I like to use the easiest possible way. 504 is an even number, right? So guess what must go into 504? 2. So I start with 2. It goes in 252 times, doesn't it? Okay, now 2 I put a circle because that's my leaf. I can't go any further than 2, can I? Right? Because that's a prime number. What about 252? Again, it's an even number. Guess what has to go in? 2. So guess what? 2 times 126. Yes. Then again, and I put a circle around 2 because that's my leaf. Because that's when I stop. 126. Again, it's an even number. Guess what goes in? Excuse me. 2. 63 times. 63 is not an even number. Uh-oh. So what must go into 63? We just talked about this sort of rule. Raise your hand if you think you know. 1, 2, 3, 4, 5. Who haven't I? Madeline, what goes into 63? 3. How did you know? Yeah, 6 plus 3 is, class? 9. So doesn't 3 go into 9? So we know 3 has to go into 63. How many times though? 21, yes. Now, 21, look at 21. It's not even, so 2 doesn't go in. So look at 21. That's pretty interesting. What must go into 21? Sierra? How do you know? 2 plus 1 is 3, so 3 must go in. So 3 goes into 7 and 3. Did you all get that?
I got 2
Okay, what's your answer then? 2 times.
2 times
How many 2's do you have?
3.
Okay, how many 3's do you have?
None. I have 1 9.
See, you can't stop at 9. Why not, guys? Yes, sir? Yeah, not. Yeah, 9 is not a prime. You can't. That's not your leap. Your leap must be a prime number. So if you have 9, then you did something wrong. You gotta keep going down.
Oh,
Yeah, 9 is 3 times 2. You see? Yeah. So Talene, what is your answer?
I have 2 times 3.
Uh huh.
And 3 times 3 times 7.
So do you think it's a good idea to write them in increasing order like this? Yeah. Right. So how many 2's do I have? 2's. How many 3's do I have? 2's. How many 7? Who can write? Now I want you to write this in what kind of form? Exponential form. Who could tell me how to write this in exponential form? Alvin?
2 times 3 squared times
Yeah. And if, of course, if you multiply all these numbers together, you get 504. Does that make sense? Any question? So do we know how to do, when they say prime factorization, you sound, oh, that sounds really hard, but it's basically just doing a factor tree. Does that make sense? And writing as a exponential form. That's all. Any question? As you can see, I wrote it as an exponential form. There. May I move on?
Sure.
Okay. Before I get to the next example, I need to explain to you or go over some of these vocabulary words again. Okay. So let me ask. I bet you already know this. Like, let's say I have number like 4 and 8. Okay, 4 and 8. 2 is a factor of 4. Isn't that right? Is 2 also a factor of 8? Yeah. Doesn't 2 go into 8? So guess what we call that 2 for 4 and 8? 2 is called the share factor. Yeah, but actually we don't call it share factor. There's actually a name for it. Yeah, common factor is correct. So write this down. A factor of 2 or more integer is called common factor. Oh, it's still 4. Is that better? Thank you. A factor of 2 or more integers is called the common factor. It says 2 or more integers because I could talk about number 2, 4, and 8 or something. You know? 2 is still like common factor of all 3 numbers. Isn't that right? So a common factor doesn't have to compare 2 numbers. It could compare 5 numbers, 10 numbers. So that's why I wrote a factor of 2 or more integers. By the way, a common factor, what's the easiest common factor you could find? Like I could give you like 5 and 7 and 175. 1 is a common factor for every number. That's easy, but that's not really like helpful for us, right? 1 is always a common factor of every 2 numbers, isn't that right? So because some of these factors, even though they're common, they're not really useful for us. So have you guys heard of GCF before? No? Some of you say, yeah? Greatest common factor. So, by the way, before I get there, sorry. So let's look at the common factor for 20 and 15. Can somebody give me a common factor for 20 and 15?
1.
Raise your hand. Okay, 1. There's always 1. Yeah, you're right. 1, anything other than 1? 1 is so trivial. That's Derek? 5. Is there any other common factor? Yeah. 2 isn't. 2 does not go into 15. 15 isn't even, you see? So 2, we got 1 and 5. Any other? Yeah. Well, that's it? Is that all? That's right. What about 10 and 1? I mean, not 10. 108. What's the common factor for 108? Yes, sir? 2 is 1. What about 1? Yeah, 1 is always there. Okay, 1, 2, 1 is a trivial one. 1, 2, and what else? Yes, Lindsay? 4. Isn't 4 a common factor? Is there any other common factor? Other than, yes, John? Is 3 a common factor for 10 and 8? 3 doesn't go into either one of them, man. What are you talking about? 3 isn't. Okay, 3. 1 plus 0 is 1, so it doesn't go. 3 doesn't go into 8, right? So only, okay, so these are the common factors, isn't that right? So for 20 and 15, common factors 1 and 5. For 108, the common factors are 1, 2, and 4. Is that okay? And so guess what a greatest common factor. A lot of you, most of the times we write GCF, right? It stands for greatest common factor. What do you think it means? Yeah, Lara?
Both of the numbers can go into that number. Like, they can be divided by that number.
Not quite. What do you think? What does greatest mean? Greatest. Biggest. So it's the biggest common factor. So for example, for 20 and 15, what's the biggest common factor? Yeah, 5. That's your GCF. What is the greatest common factor for 108? Class? 4. Does that make sense? It's just like the name suggests. It's a greatest integer that is factor of all given integer. In other words, it's basically biggest number that we're going to what? Both 2 or more of those numbers. It's greatest common factor. Biggest common factor. Does that make sense? So as you can see, like for previous one, 20 and 15, GCF of 20 and 15, isn't that 5? 5 is the biggest number that goes into both, right? What about 108? Isn't 4 the biggest number that goes into both? You understand what I'm talking about? So the greatest common factor of 2 or more number integer is the greatest integer that is factor of all given integer. In other words, biggest integer that will go into those numbers that we're talking about. Right? It's a common factor that is biggest. That's why it's called greatest common factor. Any question? Does this make sense? Yes? Greatest common factor, just like the name suggests, it's the biggest number that is common. Biggest factor that is common in both. You see what I mean? This integer is the biggest factor, right? Okay, any question? Just like the name says, greatest common factor. Greatest integer that is factor of all means common factor, right? This is common factor. So maybe I should write, instead of factor of all given integer, I could just say common factor, right? Greatest integer that is common factor. But I guess they didn't want to use that because common factor is already in the name. They wanted to use something else. Any question? So guess what we're going to ask you to do? Find the GCF, okay? By the way, how do you know for sure you found the greatest common factor? You know what I mean? Like for those 2 other examples we did just now, right? They were pretty straightforward. But how do you know for sure? Well, I'm going to show you how to know. I'm going to show you how to find the GCF. And when you follow these steps, you will know for sure that you have found the greatest common factor. Does that make sense? You don't have to guess, oh, is that the right one? So here, let's start off with something simple. I'm going to ask you to find the GCF of 36 and 90. Okay. So the first step of finding GCF is you want to do anybody have any idea? Yeah, factor tree is correct. So if you want to know for sure, yeah, of both of them, yeah. If you want to know for sure that you have the greatest common factor, right, you do a factor tree first. So for each of these numbers. So do a factor tree for 36 and 90. Everybody try, go ahead. That's step 1. Okay, I should write that down. Step 1. Anybody need more time? Okay. So the factor tree does not have to look the same, right? Exactly the same as how I have it, but your leaves should be the same. Does that make sense? So did you all get for 36, 2 to the second, 3 to the second? For 90, 2 to the first, I wrote first because that's the invisible 1, right? 2 to the first times 3 to the second times 5. Any questions so far? So that's step 1. If you didn't, be careful because if you mess up on the factor tree, right, the triumph factorization, you're not going to get the greatest common factor. So I'm showing you how to find GCF, right, and making sure how do you know whether or not you have the GCF? If you follow these steps, you will know for sure you have the GCF. Okay. Any questions so far? Are we good? So first step is to do a GCF, prime factorization. So I even wrote this down. To find GCF, step 1, prime factorization to a factor tree. Anybody know what step 2 is then? Anybody know what my step 2 is? Well, let me just show you. Oh, you think you know? Oh, okay. Here's the step 2. Write this down. Let's see what this is the most important thing. I pretty even start here. Step 2. After you do a lot of you do this well. You do a factor tree. That's fine. But step 2, you write the product of the smallest powers of each common factor. When you do that, then you have found your GCF, guaranteed. Okay. But we have to understand what this means. Okay, so go ahead and write this down. As you write this down, think about what this is talking about. Anybody have any